this is our next video on 5.2, factors and divisibility. Again, our objective for this, pretty much this whole chapter, is that we'll find all the factor pairs for a whole number, no bigger than 100. Recognize that a whole number is a multiple of each of its factors. Determine whether a given whole number in the range 1 through 100 is a multiple of a given one-digit number. And determine whether a given whole number in the range 1 to 100 is prime or composite. We'll do more prime and composite later on in chapter 5. Alright, so our problem is students in Carlo's art class painted 32 square tiles. They want to arrange them to make a rectangle. Can a rectangle have 32 square tiles arranged in 3 equal rows? Okay, that's really important. So we have 32, and they want them in 3 equal rows without gap or overlap. So if 3 is a factor of 32, then the unknown factor in 3 is the unknown factor in 3 times blank equals 32 is a whole number. So the best way to do that, if you don't know what to do with the division, then you just draw the pictures. Okay, so I have 3 equal rows. That's 1, 2, 3 equal rows. And then I need 32. So I'm just going to count threes, groups of 3, until I get to 32. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Now, does this make an even square? Or even rectangle? Sorry, even rectangle. No, because I've got this square right here that I'm missing. So I would have a remainder. Okay, so the answer then would be no, because basically a 3 is not a factor of 32 because it cannot be divided evenly. Okay, so no, 3 is not a factor of 32 because it does not go in evenly. Alright, let's take a look at another one. Alright, so these are some divisibility rules. You don't have to memorize them, but it would make your life a whole lot easier if you could memorize these. The divisibility rule for the number 2, okay, if the number is even, like 1204, okay, if it's an even number, you can always divide 2. It'll always be a factor. Okay, so if the number is even, doesn't matter how big the number is, as long as it is even, 2 is definitely a factor of it. 3, the sum of the digits is divisible by 3. So, for instance, 39 is divisible by 3 because 3 plus 9, which is just 39, right? Just put a little plus in there, is 12. And then 12 can be divided by 3, which is 3 times 4. Okay, so like let's say 27. 27 is 7 plus 2, which is 9, and 9 can be divided by 3. 9 divided by 3 is equal to 3. So 3 then is a factor of 27. Okay. 5s are easy. If the last digit of the number, doesn't matter how big the number is or how small the number is, if the last digit or the last number is a 0 or a 5, it is divisible by 5, which means 5 is a factor of any number that has a 0 or a 5 at the end. The divisibility rule for number 6 is if the number is even and divisible by 3. So if the number is an even number, just like in number 2, or for the rule for number 2, if it's even and it is divisible by 3, then it's also divisible by 6. Okay, so for instance, over here we said 36 is even, right? It's an even number. And 3 plus 6 equals 9. 9 can be divided by 3. So 36 is a multiple of 6. So 6 would be a factor of 36. Okay. 9, same thing as number 3. The sum of the digits is divisible by 9. So 54, 5 plus 4 is 9. 9 divided by 9 is 1. So it is a factor. 9 would be a factor of 54. I know that's a lot to take in, and you'll have this little cutout for your notebook, but I highly, highly, highly suggest that you memorize those. All right, so 4 factor of 28. Okay, it's 4 factor of 28. So the first thing I can do is I figure out how many rows. This tells me how many rows if I'm doing a drawing. Okay, I can also just divide if you want to do that, but in case they want you to draw a picture, you need to be able to draw a picture. So I'm going to have 4 rows, 1, 2, 3, 4, and I'm going to count to 28. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, so how do I know then that 4 is a factor of 28? I drew the square. It's a complete square. How do I know that 4 is a factor of 28? Well, the fact is that it's a complete square. There's no one's colored in over here or one colored in and not the others. It is complete. So that means it is even. Okay? I can also divide. 4 goes into 28 7 times, right? Yeah, 7 times. So 4 times 7 is 28. And I have 0 left over. I have 0 left over. Okay, is 3 a factor of 25? Okay, now on this one, I want to find out if 3 is a factor of 25. Of course, I can divide. That's always an option. Okay. But I'm going to draw a picture. So here I got 3. So this tells me how many rows, right? So I'm going to count 1, 2, 3. And if 3 is a factor of 25, what needs to happen? If 3 is a factor of 25, then 2 things. If you're drawing a picture, my square will be even. Could be a rectangle. With no remaining, right? That's really important. Nothing remaining over. Same thing with division. It's a factor if there is nothing remaining over. You end up with a 0. So I'm going to start with 3, and then I count to 25. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So if I draw a box around all of these, is my rectangle complete? Is it even? No, it is not, because I've got these 2 boxes right there that are missing. Okay? So, no, 3 is not a factor of 25. Okay? Is 5 a factor of the following numbers? Okay? If I don't have squares to draw, I've got to do division. So, 27 divided by 5. Okay? Closest thing 5 can get into 27 would be 5. And it's 25. And I have 2 remaining. So, this is a no. My divisibility rules tell me that if it ends with a 5 or a 0, then it can be divided by 5. And I know that 5 times 6 is 30. So that is a yes. Okay. What about this one? Divisibility rule. If you're not sure, divide. 5 can go into 5 one time. 5 times 1 is 5. 5 minus 5 is 0. Bring the 3 down. I cannot divide 3 by 5. Okay, so that would be like a remainder of 3. And so this is a no. All right, so we're going to list the factor pairs for 72. We did this in 5.1. We listed the factor pairs of 72. So I have 72 and 1, which I already did for you. Okay, I'm going to give you 2. So 72 divided by 2. 2 goes into 7 3 times. 2 times 3 is 6. 7 minus 6 is 1. Bring the 12 down. 2 can go into 12 6 times. 2 times 6 is 12. And that gives me with a 0. So it's 2 and 36. Okay, I'm going to give you a second to finish out the table, and then you can come back and check and see if you're correct. All right, so then you have 72 by 3. 3 goes into 7 2 times. That would be 6. Carry the 1 down. This is 12. 3 can go into 12 4 times. Minus, that's a 0. So it'll be 3 and 24. Let's see if 4 can go in. 4 into 72. 4 can go into 7 one time. Carry the 2 down. 4 can go into 32 8 times. 4 times 8 is 32. Leaves me a 0. So I have 4 and 18. 4 times 18. I don't have to go 5 because I know that 5 ain't going to work because it's not a 0 or a 5 at the end here. What about 6? 6 will probably work. Okay, 6 can go into 7 one time. Bring the 2 down. 6 can go into 12 two times. That leaves me with a 0, so 6 will work. And I can just keep trying until I figure out what works and what doesn't work. So 6 and 12. And let's see. 7, we could try 7. 7 into 72, that goes once. 0, bring the 2 down. Nope, can't do 7. How about 8? 8 can go into 7. Nope. 8 can go into 72 though, 9 times. That leaves me with 0, so that would be 8 and 9. That's a lot of factor pairs for one number. Okay, it's a very divisible number. You can divide it many different ways. All right, so be prepared for that one. That one's on a test, not 72, but that type of problem. All right, here's your homework. Okay, for numbers 1 through 1 through 4, we want to know if 6 is a factor of a number. So you're going to write yes or no. So I'm going to start with 42 because that's easy. Because I know that 6 times 7 is 42. So this is a yes. Okay. For 5 through 9, you're going to see if 5 is a factor of the number. Remember, divisibility rule. If you don't remember, go back and look. I'm not going to help you on those. So we're going to list the factors of 25. I'll do this one, number 10, for you. So we're going to start off with 25. 25 times 1 equals 25. So my factor pairs are 25 and 1. I'm just writing this variable. Okay, what else equals 25? 5. 5 times 5 is 25. And that's all there is. Okay. List all the factor pairs for 48. Make a table to help you. And you guys can do 12 and 13 on your own. Your WSQ is answer this problem. Maricela works in a flower shop. She will put 42 lilies in vases for a wedding. She must use the same number of lilies in each vase. The number of lilies in each vase must be greater than 1, but less than 10. How many lilies could be in each vase? Okay, how many lilies could be in each vase? Pretty much just trying to figure out what the factor pairs could be. All right, see you in the morning.